Hello again, everybody. So in this second part of visualizing geologic processes, we're going to make use of this diagram again. Now, the last time we saw this, what we did is we replaced the basaltic crust with the individual lithologic units that are being subducted, the sediments, the pillow basalts, etc. We're going to make use of that later, but what I want to do this time is something that'll be kind of challenging. What I want to do is map metamorphic facies onto this diagram. And what we're going to do is use this diagram we talked about in the last lecture, this metamorphic facies diagram. And what we're going to do is place the green schist, amphibolite, granulite, eclogite, and blue schist fields onto this diagram here. We'll skip the low temperature stuff, so don't worry about zeolites, prehnite, pompelliite, or any of the hornfels. That's all going to happen very close to the surface, and the scale that we're looking at here really isn't fine enough to be able for us to be able to see or even have to worry about that stuff. But I would like us to try to find the rest of these. So these 5 facies here, green schist to granulite, and then eclogite and blue schist. Now, how are we going to map these? Well, if we come back to this, remember that the green schist to the amphibolite boundary, just to give an example, happens at about 500 degrees. We can keep things simple and just call it 500 degrees. We won't worry about this little low temperature tail down there. And so what I'll do here is I'll use a drawing tool. Here's the 600 degree isotherm. So if I want the boundary between green schist and amphibolite, I'll draw a line that's just above that 600 degree isotherm curve. And then I'll paint it red so it shows up a little bit better. And then let's take a look at the amphibolite granulite boundary. That's at about 700 degrees. So we can come back here and we can draw another line and put it just below the 600 degree isotherm. Right? So far so good. We have 2 red curves, and everything that is in between those 2 red curves would represent the temperature interval for amphibolite facies metamorphism. Well, except for one problem. Notice that amphibolite facies metamorphism is cut off here by the eclogite and blue schist facies. Let's ignore the blue schist for a moment and just look at the eclogite. So that transition where it's cut off is at a pressure of about 1.1 GPa or a depth on average of about 40 kilometers. There's a range, it's not just one pressure, but to keep things simple, let's just say it's cut off at about 40 kilometers. That means that if we look at a depth of 40 kilometers, let's draw another line. So here's 0, here's 50, so, or excuse me, here is 50 now that I've drawn it. And I'm going to make it very thick so we can see it a little easier and make it black. Right? So here's 0, here's 100, there's 50 kilometers. 40 kilometers would be just above that. That means that all of this red here that I've drawn, none of that would be amphibolite facies metamorphism. This is high, even though the temperatures are correct to fit within this temperature range, the pressures are going to be equal to eclogite or blue schist facies metamorphism. Now, blue schist only occurs at temperatures of about 500 degrees or less. So everything below the 600 degree isotherm would be eclogite facies. Anything 500 degrees or less would be blue schist. So you can see the trick. So what I want you guys to do is combine these things to shade in where amphibolite, green schist, granulite, eclogite, blue schist facies, those 5 facies, where would they go? And what you'd do is you'd shade in this part of the red curve, but not below that black line. And then you'd shade in this part of the red curve here. Again, not going below that black line. Below that black line we would either have eclogite facies metamorphism, or if we're at temperatures below 500 degrees, we'd have blue schist facies metamorphism. So I want to just give that to you as a start. And so what you will do, don't worry about the mantle. So we're just going to deal with stuff that is essentially 900 degrees centigrade or less. So all the stuff that's really deep, the asthenosphere, this part of the mantle wedge, we're not going to worry about. I want you to shade in those 5 metamorphic facies as they apply to the temperatures relative to these isotherms. And then after we have that in the third part that we'll do a different week, we'll look at how those facies map to actual metamorphic rocks that you would see in the field.